Hello students, today in this session we'll discuss example number 13 onwards. So let us begin with the example number 13. So in this example it is a given that the distance of the point 1 comma 2 comma 1 from the line is we have to find here. So here the given information we will write it first. So here it is a given that the vector A. So vector A is, it is nothing but a x numerator, the constants here with the opposite sign. Okay, so we can take it as 1 comma 2 comma 3. So further I take it as a vector alpha. Vector alpha is, it is a given, so 3 coordinates here, 1 comma 2 comma 1 here, and vector B I take it as a line, the denominator, so it is 2 comma 1 comma 2 here. Now I use the distance formula. So distance between the points, it is a given as d equal to, it is a determinant value of vector A minus vector alpha cross product vector B whole divided by magnitude of vector B. So further we will find vector A minus vector alpha. It is a minus alpha, so both we have to subtract here. Vector A is this, vector alpha is this, so we will subtract it. We get it as a 0 comma 0 comma 2 here. So then here it is a d equal to, it is nothing but a cross product. So determinant we have to take it. So determinant of a determinant, it is a I, j, k, and A minus alpha, ijk coefficients 0, 0, it is a 2. Then vector B, ijk coefficients 2, 1, 2 it is. And whole divided by magnitude of vector B. So vector B, ijk coefficient square. So 2, here it is this one, 2 square is 4, 1 square is 1, 2 square is 4. So determinant expansion, we are going to get it as minus 2i plus 4j, and denominator it will be root of 9 here. Then magnitude of, it is a minus 2i plus 4j it is. So we are going to get under the square root of I coefficient square is 4, j coefficient square is a 16, whole divided by root 9. So simplification we are going to get this as 2 root 5 divided by 3 here. So clearly option C is the right answer here. Okay, we'll move to our next example. The question is xy plane divides the line segment joining the point. So point A and B are given and they are dividing externally or internally, we have to calculate here. The point P, we will take it as x comma y comma z, and we will take a ratio as k is to 1 here. So further, so we have to use section formula. So x2 is this, y2 z2, x1 y1 z1. The formula is x2, this is a m1 m2, x2 m1 it is minus k plus 2. I am using a section formula divided by m1 plus m2 k plus 1. Next we get it as a minus 2k plus 3. So it is a y2 m1 plus, so y1 m1 here divided by m1 plus m2, denominator it will remain the same. Similarly next we get it as 3k minus 5 divided by k plus 1 here. So further it is a given that, so P lies on xy plane. Xy plane means we have to take its a third coordinate, that is z as a 0. So this is our x, this is our y, this will be our z. This we have to take it as a 0 here. So z equal to 0 minus 3k minus 5 divided by k plus 1 equal to 0. We simplify it. Minus 3k minus 5 equal to 0. Therefore solution for a k is, it is a minus 5 divided by 3 it is. So negative sign shows that it will cut externally and in the ratio 5:3 here. So it will cut in the ratio 5:3 externally. So option A is the right answer over here. Okay, we'll move to our next example. The question is, so we have to find the shaded region in the figure in the solution set of inequations or inequalities. See, option A, B, C, D. So almost all equations are same. They are differ by less than or equal to or greater than equal to sign here. So here so we will observe this is a line, one line. So above part is shaded here. So above part is shaded. So this equation is greater than or equal to, we can say here, 4x plus 5y. So it is a greater than or equal to 20. We will observe it here. Okay, so it is a true here for all the values. Okay, so it is a false away from the origin here. This is a first equation. So this, it gives solution about a 6. So x less than equal to 6. So below it is a shaded here. So inside towards the origin. So this is a equation. Then next we have, so 30, RHS is 30, that equation. So we can take 3x plus 10y. So here it is 30, middle. So here we will observe it is a towards the origin here. So less than or equal to, it is a 30. So clearly option D is a right answer over here. Okay, so like this we have to find here. Okay, question number 16. The question is the constant term in the expansion of. So we have to expand it and we have to find a solution for this. So usually we will perform elementary row transformation or elementary column transformation and then we will simplify it. See, it is a very lengthy procedure. So instead of that, I do a x value as a some substitution. I take value of a x as a 0 over here. So I am going to get it as a 1 minus 1 2, then a minus 1 2 1. So minus 2 1 minus 1 here. So this is a determinant. I have taken x as a 0. I am going to get this as a resulting determinant. If we expand this, so we have to assign plus minus a plus. We have to expand this determinant. We are going to get a solution as a 6 here. So clearly option A is a 6 here. This is a shortcut trick. So like this we have to find a solution for a determinant here. Okay, we'll move to our next example. If x represents the greatest integer function, so here they have given f of x equal to x greatest integer function x minus cos x here. Then so we have to find f dash of a pi by 2. So f of x as it is, so x, so greatest integer function we will take this as a 1 and cos x as it is. Then further we differentiate this one. F of x differentiation is f dash of x, x differentiation is 1, minus 1 is a constant, differentiation is 0, cos x differentiation is minus sin x, minus into minus plus sin x, we are going to get it. Okay, so we get this as f dash of x equal to 1 plus sin x. So further wherever x is there, we have to replace it by pi by 2. So f dash of a pi by 2 equal to 1 plus sine pi by 2. Sine pi by 2 is a 90 degree. Sine 90 is a 1 here. 1 plus 1, we will get it as a 2 here. So clearly option B is a right answer over here. Yes. So we'll go to a next last example here, today's session. So f of x is, it is a having two functions here. One is not equal to 0, second one is equal to 0. It is a continuous at x equal to 0. K value we have to find here. So I am using, it is a defined at a 0, f of 0 I take it, limit. So I am taking about a point of 0 here. So f of x. F of x is not equal to value, that we have to substitute. F of a 0 is k minus 2. So LHS it will be k minus 2. RHS f of x we have to substitute here. So it is going to become sine 3x divided by e raised to 2x minus 1 here. So it is a indeterminate form. 0 by 0 we get it. So 0 by 0 we will apply L'Hospital's rule. That is, we have to differentiate numerator separately as well as denominator separately. We have to differentiate here. Here it is a k minus 2. So sine 3x differentiation is 3 cos 3x, and a denominator differentiation is 2 e raised to 2x, and a minus 1 differentiation is 0 here. Now it is not in an indeterminate form. Now wherever x is there, we'll replace it by a 0. So we get a LHS as it is. RHS cos 3 into 0, cos 0. Cos 0 is 1. 1 into 3 is 3. Divided by e raised to 0, 0. E raised to 0 is 1. So 1 into 2, 2 we get it. So k equal to 3 by 2 plus 2. Simplifying this, we get a k value as a 7 divided by 2. So this option is not there. So for this particular question, all the students, they got a grace marks here. So correct option is k equal to 7 by 2. So today in this session, so up to example number 18 we have studied. So remaining examples we discuss it in a next session. So thank you for watching this video. Thank you once again.